Welcome to the channel. We're going to be moseying around today. We're going to not be doing too much of anything important. We're going to be discussing a few theories, rotor designs, and we're going to watch this thing spin. I got a few spiral designs that I drew on the top of my rotor. And it's pretty dizzy. You know, I mean, it's fun. All right, well, no further ado, let's get down to it. Huh. All right, let's see if that works. Yeah, something's not right. Shine some light on the subject. I could actually sense how much time it took for the light to turn on. That's pretty cool. That's cool. All right. I wanted to have it directly across, and I guess I still can. Hello. There we go. Oh, that's kind of flimsy. I don't know what happened to it. All right, so we're going to call this the flux capacitor. I think it's pretty neat. It's a 12 volt parallel. So it's got 3 power sources. There's number 3. Now it's got 12 magnets on the edge of the rotor. I think it moves pretty good for 12 magnets. And we got options for drive here. We got 24 and 20 gauge in the drive. We can take the 24 out. We can take the 20 out. When we take the 20 out, we take the core out, basically. Or the 20. So yeah, I got these, the longer ones. Oh, wow. Yeah, that's vibrating pretty good. It's pretty neat. So what's up? It's Papa Bale. We're just, we're going to be like doing very little today. I mean, I got some important stuff that I want to show you. And the last live stream I did, hello, a buddy of mine shared a design with me, or a design idea. And you got your rotor. We're going to say it's 8 inches. And then you got your 3-inch by 2-inch slots that go all the way through the rotor. at 120 degrees or at 60 degrees. All right. So basically you got 3 equal holes to go all the way through. And that's where you put your coils. That's where the coils go. So I would have had it done. Hey, what's up, bro? Thank you. All right. So I already got the cores for this thing. So this is 1018 low carbon steel, a single rod that will rest in the hole on 2 brackets. The coil will go on this core, and it'll rest on these 2 brackets, and then you put 2 more brackets on the top, seal it in place. And then you got your 3 coils on the rotor. Oh, this? Heck yeah. Well, I did it really fast. All right. You get the general idea, though. Of the size of the coils will be about that big in between my thumbs. And then a little of this core will stick out and rest in the brackets. That's way it's easy to, change the coils if you want to. Now the bobbins would be 3D printed as well to fit this core and the 2-inch width design. The 3, everything goes together. All right. Well, let's discuss something else then. Ah, here it is. Can you see it though? Yeah, it's right in the bottom there. This circuit right here is this one right here. And it's pretty powerful due to its lack of resistance. And then the third circuit I'm going to turn on is an SSG. Oh, it didn't turn on. Funny. Should turn the SSG on first. It's my error. Because once it gets going at a certain clip, the bench power supply won't respond to it being turned on mid-game like that. That was close. All right, so I don't know about having the camera right there. What do you guys think? Let's see if I can back it out any. There we go. It's not too much of a difference. But anyway, I got this PLA printer filament, and it hasn't adhered to the plate, so I'm buying some glue, seeing if that'll work. I want it to be simple. I don't want it to be complicated. But I did troubleshoot that thing. I took it apart. I put it back together. I unjammed the filament that was jamming the nozzle head. Done a lot of things with it. You know, some people would just buy a new printer if their nozzle got clogged. There we go. See how slow that was going? Just to get it started takes nothing. Like nothing. Trigger coils are so sensitive. All right, so that's SSG primary drive. And that's this coil right here. Then this switch is going to operate this coil. And then this switch down here is going to operate the last coil. I think that's pretty good. Look at how small those coils are. I mean, literally, there's probably 1,500 turns altogether. Maybe. Because I think each one of the white bobbins is 450. So that's 450, 24 gauge in the drive. And then I don't know how many turns the little bullet ones are. That's what I'm going to call them, man, because they're, boom. You know, I'm going to take the 24 gauge out, leave the trigger strand in, use these 20 gauge coils that are behind it by themselves, and we're going to see what happens. But that's pretty smooth. Got two ceramic bearings in the rotor. It's mag lifted, so it's resting on a toroid. And it's frustrating, man. I got this thing, it's all ready to print. I got the cores ready. Just need to print the bobbins and the rotor, and my printer won't do what it's supposed to do. So I got a new print plate coming, and I got some glue coming. Should get me past the first layer. That's the only thing I'm having problems with right now is like the first layer. And I don't understand, man. It's been printing on the same settings since I bought it. And everything's been printing fine. Like 100% okay. Then it stops printing. So I take it apart, and it was making a clicking noise, so I took it apart, and I saw that it was jammed. So I unjammed it, I put it back together. Now, it could be one of like three things right now. It could be the hotbed temp is too low. So that's another thing I'm going to try and just meddle with. It's on 50C right now. It should be on like 60C for the PLA. But like I'm saying, I haven't had any problems with PLA, PETG, any of it. I've been using the presets and it's been working fine up until now. That's what I'm saying. So I can understand why people would buy a new printer, you know, because it works right off the bat. Anyway, that's nearly sorted out. I hope the glue helps. I hope it's an easy fix. Because, I mean, damn, it's just a, yeah. There's got to be a way to fix it. Like, make it so it sticks to the plate right and doesn't melt. Or warp. You know, that's what it's doing. It's warping and then it's catching on the next layer. And it's right off the bat. So there's, like, nothing to see here. You know, it's crappy from the start. And it was doing this before I took it apart. So it's not the fact that I opened it up and untangled stuff. Has nothing to do with it. Because I put it back together tighter than they had left it for me when I bought it. You know, it was like, it was a good thing that I opened it up. And you know what? I used the Allen wrench, man. I didn't use a hammer. Anyway, I think that's really smooth. I'm going to take the camera off, let you get an aerial view. I think it's sweet. I got an outward spiral and an inward spiral all on there at the same time. Now this is my lab coat that I'm wearing. I currently don't have a white one with my name on it, so I'm wearing the next closest thing that I have. Heck yeah. Get my name, put it right here, Papa. No, that's not my name, but it is for this show. Oh, that's so sweet. I'm glad I did that because I got the paint on the bottom for the base and it's already looking swirly. You gotta pardon me though, I'm sucking on Halls because my throat is messed up. It's been messed up for 3 weeks. But it's starting to feel better. All right, so I'm thinking, what am I thinking? I am thinking, we'll see what I'm thinking. I want the electricity to stop coursing through this thing. So I'm going to stop it. All right, so we're going to take out the 24 gauge. Now the drive is just this coil in the back. That's going to be fun. All right. That's two of them. On this third one, I need my screwdriver. And I'm going to need to move the camera. Maybe. You know what? I'll leave. I don't know. Maybe I can do it from the other side. All right, moment of truth. I haven't done this yet, so there it goes. I think it works better with the more wire. But, you know, technically it should work better because it's a bigger gauge and it's shorter. Maybe it's just going to take some time. Who knows? Oh, that's looking good though. I'm setting up the frequency generator real quick. Oh yeah, it's getting really fast. Woo! Oh yeah, it's pulling like an amp too. That's awesome. All right, let's see. Mm. So solo coil, the soil, doesn't generate enough on this for it to turn on this light. But with the sandwich, if there's enough, but you need it to be running parallel, 2 transistors. Yeah, you can run it on 1 transistor, but it's not the same. But you gotta have both coils. You can either run them in series for the same transistor, which is okay, I guess. All right. So I'm gonna hook them up in series. See if that helps. I don't think it will. I think you need separate power supply and a separate transistor. But I got it lit up yesterday, but I was using a way different setup than I am today. And now that it's 2 coils in series, I should probably double the voltage input. Instead of having 2 parallel 12s, I gotta have 124 now. That's another reason why the parallel setup is better. It keeps everything in perspective. So at 12, we're generating 50 volts of DC electricity in the sandwich series connection from the coil in the middle. I'm going to turn it up now until we draw 100. There we go. Yeah, I got the drawing or the STL files on my phone. So 24 volts, 25 volts, 100 milliamps. I'm going to turn the switch on. Oh yeah, we got a little bit of light. Nothing spectacular. Yeah, it works though. It's a big LED. It's like 15 watts. Without it on, we're doing 78 volts at 25 in. And with the load on, it's 49 volts. So we're doubling the voltage with the load coming out of this thing than what we're putting in. But if I hooked this 24 volts of the power supply up to this light bulb and then turned it on, it'd blow the light. So, but there's a lot of voltage coming off of this. I think it's really neat. We're doing a sine wave. Series connection with the top and the bottom coil, using the middle coil as a receiver. We're gonna try and tune this light into existence more so. It's working. Every hertz is making it brighter right now. It's going to get to a point where if I add more frequency, it's going to slow it down in the voltage department. But right now we are way below a resonant frequency. I would assume, since it's going up so much every click here. But I'm measuring it in hundredths of a volt. So we've only gone up like 3 volts so far. 4 volts maybe. Wow, we got a nice. But this is at 24 volts in, 25 volts in, 200 milliamps. I'm going to get a shot of the scope in a second here. Let's turn it this way, see if you can see it. You really can't see it. Alright, I'm going to get the camera off of the stand. I'm going to show you what I'm doing. We're at 248 hertz right now. Continuing to increase the hertz. And look at our light. It's starting to get really a lot brighter. Just from playing with the frequency. Oh yeah, and there's our light that we're using. Our halogen bulb. It's really jamming right now. At 25 volts. It's like 300. seems to be right around our resonant frequency for these two coils together. Because I'm going to turn it up. See, our voltage is not going up. It's going down for going up in frequency. So you got to back it up a little bit. $300. Awesome. So these two coils are sandwiching our receiver coil, and we're getting some output. It's not great, but it's not too bad either. That is 12,960 turns of 32 gauge in the middle there. All right. I'm going to put this back on the stand here. I love making this thing like hum. It's great. We're getting enough output to light up every LED in the LED. So I'm kind of happy with that. You know, there's more than one way to cry about stuff. You can totally ignore the person you're crying about. That's one way to cry about stuff. You know, I make one joke about time travel and I don't know, man. Mm. All right, so a buddy of mine assured me that this is not this particular one, but there's a way that you can travel in time using a pulse motor. So I'm going to build my idea of what that pulse motor would be using quote unquote the specifications that thusly have been given to me. So there's going to be 3 electromagnets on a rotor in the middle. They're going to be 3 inches, or let me think here, 2.5 inches in length and up to 2 inches in width. They can be circular, they can be square, just as long as these are the cores. These are the shafts for the coils. They're going to fit right in the rotor. What the hell just happened? Yeah, who saw that? Oh, they got more scared than I did. Oh, man. Oh, well, I mean, that's a given. We're going to have to give it a rest here. That went through the duct tape, just to let you know what happened there. I had it taped down, glued in, and it's still, with the forces that be, flew out of its little holder. That's uncool, man. But see, this is an old design. You see how the magnets are on the edge of the rotor? There's no real way to keep that secure. So I started making my rotors a different way. But that's a good demonstration of why you shouldn't do it that way. See, you put it so it's inside, so it's encased in PLA instead of needing to tape it down. And even duct tape doesn't work. The force involved with doing this is, especially when you're going at certain speeds. And that one was going pretty fast. Wow, man, it ripped right through the tape. There it is. Right here. Holy smokes. All right, so we're going to put that one away. That's too bad. Maybe we'll work on salvaging all the rest of the magnets. And just for a note, I'm glad it didn't hit me. I've been through a lot of, can't say a lot, like 3 instances like this with my old designs. So if anybody wants to see that, that'll be available later on this evening. I didn't exactly see what happened. I mean, I saw the aftermath, but I didn't exactly see what happened. My amethyst ball went flying. It didn't break though. I don't know, that was just one layer of tape though. I think that's very not cool. I'm just trying to think. I don't have much to prop it up on other than what it's on already. And it's too high anyway. Well, that'll be sweet. How about I do 120s with this 90 degrees? See if it'll even come together. Oh. Oh yeah, that's gonna work good. Just need to get, because it's the coil in the back that I'm trying to line up. That lines up pretty dang good. All right. Oh, another thing is I don't think AI is out to get us, or it's gonna, you know, for every bad AI, there's gonna be a good AI type deal. So I'm not worried about it. Now, if I do this right, they shouldn't ever hit at the same time. I love that shape. It's a toroid with 4 spokes. So it's kind of like a wheel with 4 spokes, and then the spokes extend to make fins. So it blows a lot of air around too. All right, let's see here. Let's Sounding pretty good. Oh, shoot. Yeah, I see some damage. Transistor got like knocked pretty hard. Let me see if it works. Oh, well. Turn this one off. All right. So we got a I'm going to try it like this. Because I keep on having this image in my head of something that looks more along these lines than something that's totally symmetrical. There we go. Oh, I can feel the wind all the way out here. That's awesome. All right, so I admit it. Got a little bit of shaking up over that rotor blowing up like that. Still can't find the magnet. Surprisingly little damage though. Let me just make, yeah, wow. These bearings are a little loose. Just had to put them back in there again. All right, so our goal is say 1500. So that's going to be 6,000, I think. $4,145. $6,000. That's 1,500 right there. $1,600. There's gonna be 6,550. Yep, 6,554. Okay. So right around 1,600 RPMs. I imagine the torque is pretty good. I will be right back. Okay. Now the rotor that I'm going to be building and maybe sharing with a few people. Actually, I'm open sourcing it, but I'll directly share it and explain how to build it with a few people. It's going to have 3 slots that are 3 inches by 2 inches at 120 degrees. And then it's going to have coils that will be on these, and these will rest in the holes. These are 3 inches. There's going to be brackets inside the holes that these will rest in with the coil. It should fit snug the way I print it. Now the only problem with rotors like these is, I tried to reduce the material. It turns into big fan blades and it's going to catch a lot of wind. But if you keep it round, the only other problem is how to power it. You either have to use a commutator or you have to have your power supply on the rotor itself. That's how I do it. All right, see, I got my coils, and because my coils are moving, I gotta have my power with my coils, so the power is moving too. We got a battery here, a battery here, and a battery here. They're all 12-volt battery packs. Only 2 of them are hooked up though. Third one's just to balance the weight. Now it rocks the table a lot less than it used to. It counter rotates. It's just a pulse motor where the rotors go opposite directions. And there's 2 rotors basically. This is the rotor that it goes with currently. So you got your 120 mags with your 120 coils. Now there is speculation that these things are supposed to allow you to manipulate time and space. But I don't really believe in that because I haven't seen it yet. But each idea put forth is different than the last, so I can't necessarily say that it doesn't exist. Because you don't know. You don't know. You don't know. I mean, what we do know is that it mathematically could be possible. Now, having the coils in the middle, I might be able to set this up right now, actually, because I got the coils on the rotor right now. Oh, we're going to do that. Oh, we're going to do that. I hope, for the love, that, oh man, I should just test it, make sure. Where's my tester? Was right there. Oh man, that thing. Of all the things that I usually misplaced, that is the thing I misplaced the most. I see it. Because of the toroids are opposing each other, we can get rocking right now. Dang, should have thought of this before. Gotta move these out of the way. All right. Dang it. Dang it. So we gotta lift this up and center it. Unless it's south, but I'm pretty sure it's north. Yep, okay. Dang it. Dang it. No sweat. It balances off at about 1,000 RPMs. Doesn't go very fast. But we're going to see what happens when I stabilize the top or the magnets. And just the coil spin and axial flux design. Okay. Because I was told, I heard that having the counter-rotating pulse motor will go faster. At least twice as fast. this shouldn't take long. Actually, I have quite a few of the common rotators. I think I've built 4 of them so far. Built them with commutators and without. Now what I really need is reed switches. All right, we'll get a transistor in this bad boy. I guess we can see if that's lined up right. All right, so too low. It's too low. I gotta raise it up a little bit. I gotta get a new nut for this thing. It's not. God, that's not good. Nope. This thing's been on the floor. My cat's been walking by it. I don't know. Everything looks good, but I don't know. You know what? I'm just going to get one more bearing to stack on there because I think that'll work just right. This is a counter rotator, but I'm going to try and hold the magnets still and allow the coils to spin. Just got to make sure that it's working first. And I don't try to do anything. It's totally loose. All right. But yeah, this is a Veriforma of pulse motor. But I wouldn't say it's a Bedini or an Adams or anything like that, really. Not this one. Yeah, I don't think it's working though. Maybe it's too high. I don't know. I know what might help me though. A little bit of light. Here. That sounds right. Yeah, all right. See, I need reed switches to make it work the other way. But yeah, this thing is fun. It's riding a little high on the pole though. So I want to make one where it's just the magnets are still stationary like this, and the electromagnets are the only thing spinning. All right, so I'm going to try and, like, instead of pushing the bottom, I'm going to try and just spin the top and get the bottom to start on its own. Well, it already started. Isn't that something? I didn't have to touch it. It was like, giddy up. But it's at about 800 right now. So it's about to be 2,700 divided by 3. So that's like 900, right? Looks like the bottom's slowing down too. The batteries must be low. 2,700 divided by 3. All right, let's just try spinning. bottom. Oh, look at that. I didn't even tell it which way to go. That's awesome. Runtime on a full battery. Well, I'm so much in and out of it being on. There's my magnet. Oh, I'd say the full runtime, depending on the coils that you're using, is anywhere between an hour and a half to 3.5 hours at like peak performance. For these batteries anyway, 12 volt lithium ion, rechargeable. Let's see now, starting it with the bottom. Oh yeah, it's going to be the same, about 900 to 1,000 RPMs. Let's take a look at what's under the hood. All right, we got a direct connection on our transistor. So it's one connection for the base, one connection for the collector, and one connection for the emitter. Got two resistors, I believe they're 150 ohms, one for each. Used to be two transistors in here, but now I just use one. These are Bifilar wedge-shaped coils with, I want to say, they're hand wound. I want to say they're 250 turns of 32 gauge and 20 gauge. So they're real small, but then again, I rolled them so that they took up more space. They're a little looser than my typical wind. But as you can see, they work pretty well. They're printed on iron infused PLA, excuse me. They run on this trigger coil right here. So one trigger, they're all in series. So it's one trigger coil, fires them all off. And they line up really well with the magnets on the rotor. So you got your trigger coil right here. Both your resistors are hooked to the trigger coil. Trigger coil goes to the board on both slots. So there used to be two transistors here. So there's two connections to the trigger coil, since there's only one of them. And then the collector, the battery, all the batteries go to the collectors. And then the emitters go back to the batteries. No real need for anything else, as you can see. I mean, like if you wanted to go a little bit faster, you put a resistor in there that is, well, actually, no, it's already got resistance. So, I mean, it's pretty good the way it is. The trigger coil's got its resistance. But another thing you might be able to do is germanium, Zener, something like that across. I don't even know where it goes, but probably base to emitter. Oh, for sure, man. Not for this one. Not even thinking about it for this, but like maybe making a completely new one, maybe transferring the coils. Every time I build one, the design gets a little better. But then again, my objectives and my goals are different, way different than everybody else's. I mean, I'm not trying to change time. I'm not trying to ride time. I'm not trying to do anything with time, but that's what these things do apparently. I like the spinning. I definitely like the spinning. I got a toroidal pulse motor, where it's a stator, but it's also a rotor. It goes along the outside, so like the outside, and it spins this way. Well, the center magnet spins around like this. Counter rotator. It's pretty cool. And my printer has taken a dump. It might be the filament I'm trying to use. It's glow in the dark PLA. I'm trying to print an 8-inch rotor with spaces in it to hold coils. 3 coils to be exact. And I got 1018 low carbon steel cores for the coils that would go in this rotor. I just can't print the rotor right now. It's pretty ridiculous. So I got another print plate coming in the mail, because that might be what it is, the print plate. Mine's pretty dirty. 900 RPMs. And then we got, oh no, we need to get some glue stick in case the print plate doesn't do the trick. Because it's just that first layer. I'm pretty sure everything after that would be fine. But it warps, it gets like, but then the filament might not be worth a damn. Oh man, I love that though. That's a good one. Let me show you the first one I ever made. I got that one. All right, so it's run on a commutator. It's run on a reed switch. And its outside spins one way and the inside spins the other way. It's not hooked up currently, but that's it. This is the original. Why? See, I don't have an answer for your question. That's just that's a different way of asking the same freaking question. What's the purpose? The purpose is for me to have fun. Someone suggested that time travel is the purpose. I don't believe in time travel or necessarily time even. So I don't know what you guys are getting at when you're asking me what the purpose is. I mean, I'm not trying to make anything that will go into like a vehicle or anything like that. I'm just demonstrating principle. You know, every single one of these things wants to spin in opposite directions. The coils want to go this way, and the magnets want to go that way. On all of them. And that's my theory. Doesn't matter whether it's an Adams, a Bedini, freaking any of them. All of them want to do this on their own without help. So the purpose, I guess, is to prove a point. I don't have like I didn't start out that way. I didn't start out by asking myself, why am I building this? I just went for it. Maybe. Um, I wouldn't like say it's for that, or it could be good at this because that's just not the way I roll. I would say this is like a rudimentary example of something that might work in that situation. So yeah, like if we had a cataclysmic event and everything that is being automatically made right now in this regard suddenly stopped working and you had to use something like this, yeah, it would probably work. Absolutely. But yeah, I don't know. Like I didn't like most people that are doing this are doing it for like a business. They're like trying to make something and sell it. I can't even get my 3D printer to work like do more than 15 prints in a row without pooping out on me for some reason. So I can't even say, hey man, I can print you something. Can't do it because my printer's not reliable. And I've taken it apart, I've put it back together. It works. Right now, I think it's just the print plate is really old and used, and I don't have any alcohol. So I'm getting a new print plate, and hopefully that'll solve the problem. The PLA that I'm using is questionable as well. It's glow in the dark filament. So, I mean, that's what I want my next rotor to be, about this big, glow in the dark with 3 holes in it that I can put the coils and bobbins into and then glue down. And then you've got your rotor with your 3 coils in it that have their cores and everything all ready to go. I am from the United States, Michigan. And I mean, it's weird because I have no desire to control time in any way, shape, or form. And it's ironic because all the people that are working on it that I know, I might be the first one to get there. Just using the designs that we have right now. I've been trying to get a hold of my buddy so I could give him the plans, but he obviously thinks I'm going to do something that I'm not going to do. I'm waiting on my Discord for you to stop by, buddy. And I believe that's the only place it's going to happen at. I've got other chats and stuff like that that I can use. And I've dropped it in the Discord, your Discord. And you know who I'm talking to. That's a first draft. But, if you don't want to use it, that's okay. I'll use it. Okay. Thank you. I appreciate that a lot. You're damn right, man. All this started from a thought, like just a thought. And I was like, how can I get the wheel to spin without me spinning it? And I didn't start off by looking at a DC brushless motor. instruction manual. That's not where I started. Started asking a question. I didn't even know what a DC brushless motor was. I didn't even know. I have absolutely no desire to disrupt time. I have very strict beliefs on what will happen if you go backwards in time. If you go backwards in time, the present that exists right now would not exist at all, anywhere, for anybody. You don't think the butterfly effect is real? It's real as freaking hell, dude. And if you go back there and your energy is back there and it's not supposed to be there, you're going to change all the energy around you. Resonance is real, people. Believe it or not, you're more like a Tesla coil than you realize. It's just an urgent warning. It's like there's no reason to go backwards in time. Now, forwards in time, that's a whole nother story because that hasn't really happened yet. Although it's already, all of it's already happened, but it hasn't happened yet. So when I was making fun of time travel the other day, and I was like, hey, World War III has already happened. World War X has already happened. And guess what? The world keeps on spinning. Okay? The world's going to keep on spinning. If your objective is to stop the world from spinning, you're not going to succeed, and you're more than likely going to die in the process. Yeah, I'm just like, who's worried about what? I mean, the world's not going to end. It's like, and I don't care who you are or what you think you know about like the world continuing to spin. It's going to continue to move. And especially if it's hollow. Okay? Especially if it's hollow, if there's a lot more water. You know, I've heard tons and tons and tons of theories, man. All I know is that the world is going to continue to spin. Even when it like gets shot out beyond its, you know, and we start moving farther away from the sun. And everything gets really cold. Yeah, I mean, I I have like a gift and a curse. A lot of my friends have died of cancer. And so I end up making friends and they end up getting cancer and they end up dying. And so, you know, I don't know if the two are correlated, but it's happened enough times in my life for me to think that that could be a thing. Okay. So I understand how some people might want to go back in time and maybe change some things in their life that they thought wasn't fair. No. The answer to that hypothesis is no. And it doesn't matter if you can do it or not. That's not the point. Time travel is tricky, man. So yeah, like if you're planning on going back to right some wrongs, maybe never pick up that first whatever and just forget about it. I implore you to let it go. And like I said, it's really not about whether you can do it or not. Because I believe it's been proven that a proton or an ionized proton has been seen moving in reverse in some sort of particle collider somewhere. I mean, there are people out there that says it wasn't possible, but I never said it wasn't possible. I just said you shouldn't do it. Because there are consequences whether you, because man, all you got to do is set foot outside your created environment and your resonance is going to affect everything it touches. Not just you touching something, but the quote unquote stink of you being there is going to mess everything up. Can you do it? Yeah. And I believe this is another way like throngs of souls get lost because maybe people have been doing this. And they just get displaced because everything that they were working on doesn't exist anymore. Only destructiveness can come from going back in time. And you know, like the Marvels, Avengers, I thought the idea is awesome, but no, it doesn't work like that. You can't exist back there without leaving your imprint on whatever's back there. And the way I know that energy works, it'll ripple, your energy will ripple until it either hits something or it's stopped in other sort of frictional ways. It'll reverberate to the end of this universe if it doesn't hit anything. So yes, you go back in time, you are messing everything up. All right. Moving on. Said 3-4 times that it's beyond really being possible. It's definitely possible. And I don't think it's really the speed, because everything's already moving at a phenomenal rate of speed. Like if you think about how fast the Earth is spinning already, just use that. And that, in order to do that, you have to resonate, have your environment resonate with space. So that way you can interact with the Earth not on its terms, but on your terms. And your environment will then be moving past you at 16,000 miles per hour. And I don't know, like, I don't know about the 10,000 times the light speed of light. I don't know if that's a thing. The more impossible that you make it, the more it sounds unlikely that that's a thing. 10,000 times the speed of light, or is it the speed of sound? There might be more than one way to break this rule. But yeah, that's how I feel about it, man. Everything's already been done. It's already been done. Everything exists everywhere at the same time, and it's all already been done. And everything out there is moving really, really fast. Okay? You would think that space is still, right? But space is more connected to the ether than anything else, and it is not still. It's just void of gravity and air. I think that Star Trek Beyond got it the closest when Scotty said, you know, he was developing for like warp speed travel, and it was something along the lines of space is actually the thing that's moving, and you're just hitching a ride, basically. I think once you get inside the atmosphere of Earth, things start to slow down a lot because you start moving at the speed the Earth is moving, which is really, really fast. And it's relative because the atmosphere of the Earth, or the energy that emanates from the Earth, moves at the speed of the Earth, and you are now become part of that energy once you enter the atmosphere. And it has its pros and its cons. It's expanding in lots of different ways too. You got dark matter, you got dark energy. Those are helping the Earth or the space expand. You got the things in space that are moving away from each other, giving the appearance of expansion. But really, they're just moving away from each other. And I mean, like galaxies. All right, here, man. I love this. Let me do this real quick. Speaking of expansion and growth, yeah. All right, you got two objects in space, and they are thusly apart from one another. They're moving in the same direction. Are they ever going to touch each other? Yes, sir. This is the flux capacitor degenerate. That's what we're going to call it. Okay, so back to my question. You got two objects in space. They're moving at the same direction and at the same speed. Are they ever going to touch each other? Is there a way that they could touch each other? Think about resonance from a Tesla coil. It's typically growing. If they grow into one another, they can touch each other. But physically, never going to happen. But if they keep growing resonantly, they will affect each other. They will touch each other resonantly. Yeah, they will. Yeah, they will, dude. Absolutely, 100%. Their resonance will touch each other, affect each other. But they will never touch each other. But they will know that each other is there. They will be able to talk to each other. But they'll never be able to touch. It's just somewhere in time. That's what I'm calling that theory. right. But yes, absolutely. Although touch, the word touch is a physical, gives a physical connotation. You know, touching something, that's touching something like this. But if you use touch as in notion, you know, like a different way, different meaning of the word touch, like a resonant frequency. Yeah, yep. Time and space. Let's walk through the portal, everybody. Rabbit hole. Jump in. Yes, I can't say either way, man. I've had many of those experiences with and without apparatus. So I know that you can interact with it. Do you need tools? So a lot of people need tools to interact with it. All right. No, like you would say that space is an empty container, right? You draw a box, 3D box in space, and you say there's nothing inside of it. That's BS. If there is an ether at all, anywhere, it's everywhere, okay? Including space. Now it's probably interdimensional. Ether, you can't see it, you can't touch it, you can't smell it. We can barely interact with it, and yet we kind of know it's there. Okay, so everything existing everywhere all the time. Okay, and it's moving really, really fast. Because if it was still, you'd be able to interact with it easier. We would be way farther ahead than we are now if it wasn't moving at a phenomenal rate of speed. So what I'm saying is Marvel, the Dark Elves, that whole scenario is virtually the opposite of the way it really works. It's not like a slow sludge, amber-like material. It's not like that. And I guess to really understand what's on the other side, you got to go to the other side. Because it's not mathematical. There's no math that will prove it. And all math, according to the way we do things, will disprove it, as a matter of fact. But, I mean, things are changing. Things are always changing. That's why I don't like to get like a crisp education. I like to have it be kind of like a, you know, expanding education, because what I learned 20 years ago and what I learned today about the same freaking things is totally different. I mean, there are some things that stay the same, but you know, so many things have changed. I mean, the whole millennial generation thought they could redefine everything and then make words mean something else. And that screwed up things a lot. I mean, that, I just say like the generation after me, because it didn't happen really when I was going through school. It happened after I got out of school. And I think it's all good because that happens a lot. You know, the dictionary gets changed periodically. But it makes things confusing. I mean, one thing that we need to redefine for sure is the banking system. Yeah, you don't have to see it to know it's there. It's kind of like believing, right? I don't know. I would feel better if I like. And yeah, light is just one thing. Light is a photon. Light is everything except what you see. Because your eyes, that's how eyes work. So everything except what you see is what's out there. Hey, what's up, society? All right. Well, you know, if you end up, you know, go floating through time, you send me a postcard. I'll give you a time, a place to drop it off at. Yeah, I don't know the first thing about it, but I'm pretty sure that if it has anything to do with what's on the table right now, um, we're only a hair trigger away from it, you know? I just have to print off a new rotor. I'm waiting on a plate so I can do that. I'm trying to get Hall Effect 10 so I could share this with them. Yeah. I'm trying to print a rotor, but I haven't been having any luck with the adhesion to my plate, so I bought a new plate. Gonna use these cores for the rotor. It sucks, man. I got like everything ready to go, and I just can't print the rotor. It sucks. I mean, the max RPMs on this thing is 1,000. So I would say it hinders it quite a bit using the external trigger coil. But I got a 20 gauge strand going through all 3 coils that I can use for a trigger. It'd be more appropriately timed. But I would say that, yeah, what it's supposed to do and what it's doing are not the same at the moment. So I was thinking about doing reed switches, 1 reed switch for each coil. And then having, because this is Halbach's idea, have a reed switch for each coil and use shorting to run it, basically. Oh, if you were here earlier, you could have seen the catastrophic failure my rotor had. It really sucked. See that hole? Magnet flew out through the tape. I see it now. I found the magnet. Yeah, it was a doozy, man. But I found the magnet. That's good. There's a big chunk of it missing. So as soon as I can print this rotor, I'm hoping the new print plate will help sort that out. I'm going to make a radial one like the coils. The coils are going to be out here, or I mean they're going to be magnets though. The perm magnets are going to be on the stator. And I think I'm going to use a commutator. I mean, that would make sense, I think. Oh, I think it's about an hour in, maybe less. So when I'm done and it processes, if you want to see it. I didn't catch the exact time, but it's like kind of in the beginning. I think it's going to work a lot better because there's not going to be a bunch of stuff on the rotor making it off balance. Making it so off balance, and it'll go faster that way, I'm pretty sure. So if you want to see what I'm talking about, I got it posted on my post section on my channel page, my community section. Oh man. And I put that rotor away for a long time because of a catastrophic failure that I had previously. And then I glued it, thought it was going to be all right. Taped it down even when I thought it wasn't going to be all right. Oh yeah, batteries are getting low. They're still pretty up there, but it's down to like 1200 RPMs instead of 1500, which is quite a drop actually. Oh. The RPM would be double, right? It would be, um, I understand what you're saying. Each rotor has a different RPM because of the mass. And I agree with you. I mean, all I would probably have to do is get some weights, like little metal weights, and maybe put one on here, like a little 1.5 pounder. Because that's it right there. You don't mess with the one on the bottom because look at that. You just messing with that would be stupid. You mess with the weight of the top one, which is really light. You just add, to it. I think the one on the bottom weighs probably 2.5 pounds. It's got a donut toroid on the bottom. It's got 3 coils that are pretty big. It's got 3 batteries on it that are pretty heavy. But and I don't even consider using mass as an appropriate. It's weight. That's the only thing we're going to be working with here is the weight. Maybe that's how you measure mass. I'm not exactly sure. It's been a long time since I did any science homework. But yeah, as long as we're talking about the weight, we're talking the same thing. And what I hear though, not only will it be equal, the RPMs would be equal, but they would then start cascading and the RPMs would increase altogether. At least that's what it's supposed to do. Once it gets going and they're both of equal mass. I mean, the size isn't going to get any similar than it already is, but the weight can change. Because it's an 8-inch disc, that's 3/4 of an inch on the bottom, and it's an 8-inch disc that's 1 inch on the top. So, and I made the one on the bottom smaller because of the weight disparity. And it's also probably 50% infill, whereas the top one is probably 15. But I had this one going so fast. Well, I had the axial flux going so fast that even when it was encased in the rotor, it broke out of the side. It was going so fast, like literally 3,000 RPMs with that much PLA holding it in. It didn't work out that well. And the only problem with it was that I left a small space so that I could easily remove the mags. And that was enough to have vibration in there that was enough to totally destroy it. So you can hear it in this one. It was like that, you know? So you didn't have to put any effort in taking the magnets out. And I feel like there's a lot of show me this, and I feel like saying the same thing. Show it to me, and then I'll be a second mover on the whole thing. You know? I don't mind being the second mover here. Damn, I just wish my printer would work. Oh no. Now it's backed out a little bit farther, and we're going to see what a little bit less lens effect will yield. Oh yeah, we're already up there. 900. Wow, we're really close to 1,000. But it's moving really slow on the bottom. So I don't know. Maybe they got to be stronger magnets on the top. Maybe more time. I'm not sure. So 2,900 divided by 3. I don't think it's going to go any faster. Sweet. All right, so let's explore for a moment what we could do to make the mass of the top rotor be the mass of the bottom rotor. And we're going to find out exactly how much that's all going to cost. Okay, we're going to break down price. We're going to break down what we could do here. Looks like I have 2 toroid magnets that are available that I could just put on the top of this thing, and that might do it. Let's try that. And let me get my scale. Yeah, this isn't going to work. Looks like somebody took the battery out. All right, I'll be right back. All right, so we're going to put, let's see if it'll even work. Don't have a lot of pull there. No, it doesn't look like it. Okay, so this is what we're going to do. All right, we gotta flip it over. It's gonna suck the magnets right out of their holes. All right, let's see about it now. It's because it's axial flux. Huh, the magnets might not work because of that fact. Huh. Well, I know we can try. We're going to try a Halbach array. Now this way, the magnets shouldn't be directly attracted to each other. No. Right. But I gotta kind of make sure now, I guess I can put this on there anyway, that it's gonna run it at all in a Halbach. Now I have, it's a give or take, it's on and off, happens sometimes, doesn't happen other times. Because it all depends on how sensitive your trigger is. Right. See how one does. No, it's definitely still too light. We're going to see how it changes. Something must be loose. It's hot, man. I'm hot. Burning up over here. I don't think that's on though. Oh, that breadboard. I don't even know. It might be the magnet interacting with the electromagnets now. Looks like what it might be, actually. Oh, it's the Halbach array. Damn. Yeah, that's. I don't think it's gonna work. Haha. Not with these kind of magnets, anyway. See if we can get enough speed for it to kick in. Yeah, I don't think so. All right, so what we're gonna do, now that the magnet is in place, I don't know. Thinking the new build is going to be ferrite magnets instead of neodymium. All right, now let's give it a whirl. That's already looking like it's working better. Just the center's a little off. No, not better. Now it might be the batteries, but it's definitely going slower. But I can see it kind of trying to move at the same rate, a little bit more so than before. Heck yeah, that's pretty dope. All right, so yeah, I'm bummed, man. I really want to print this thing out and put it together and then prove that it's going to be smooth as SAF. Yeah. Then I want to pass it along. It's totally adjustable. This is just what I'm doing. These are going to be the cores for the coils in the new 120. And the coils are going on the rotor. And then I am actually going to have a stator made with permanent magnets. I got lots of permanent magnets that I can use. I think I'm going to use toroidals like this. But I have big round flat ones too. They're totally flat. All right, well, you know what I'm going to be working on the next couple days. Thanks for coming by. If you want to see the big rotor catastrophically fail, go back to the beginning of the stream. It's somewhere in the beginning there. Thank you. Bye now.